Well, hello everybody. It's now time for a new section, a new chapter. That's right. We're going to begin learning about moles. What the heck are moles? Well, moles are a unit of measurement that chemists use almost exclusively. Not many other science disciplines utilize the mole as a unit of measurement. It belongs to us, the chemists. Pretty much no one else. What are moles? Well, that's kind of hard to describe right now. But I can tell you that moles will be the star of the show for the rest of the year. Since moles are a unit of measurement, you can expect that most of what you're going to do in chemistry from here forward will involve mathematical computations. Oh dear. Yes, math can be tricky. The rest of this year in chemistry is going to be tricky and complicated. So be ready. But I'm not going to teach you much about moles today. We're going to step back a little bit and do something that's even more fundamental and basic and crucial for the rest of the year, and that is something called formula mass. What the heck is formula mass? That'll be made clear in the near future. All I'm going to do today is teach you how to calculate it. Calculating formula mass is not terribly complicated. However, it is important to understand that formula mass is the basis of everything else we're going to do. So what you're going to see today is not crazy and complicated, but do not mistake that for something that is unimportant. You don't want to blow this one off. You want to take formula mass seriously, because if you cannot calculate formula mass, everything else that we do is going to be a disaster, and nobody wants a disaster, right? Excellent. So what will you need for this here lesson today? Well, you'll obviously need a calculator, because we're going to be doing some calculations. I'll be demonstrating them to you. And also your good old friend, the periodic table of elements. With all of those things in place, it's now time to see how to calculate formula mass. I've got 3 examples to show you. The first one is this compound called magnesium chloride. Ignore this one for now. That's our second example. So how do you calculate the formula mass for magnesium chloride? Well, it's not all that complicated. First, list the elements in magnesium chloride. Okay, so magnesium chloride is made of magnesium and chlorine. Wonderful. That's not that bad. Now, next to each symbol that I wrote down, I'm going to write down how many atoms of that element appear in the formula. So I'm looking at magnesium right now. I see an invisible number 1. There's 1 atom of magnesium in this formula. The subscript after chlorine is 2. That indicates there are 2 atoms of chlorine in this formula. Great. What's next? Look up their masses on the periodic table. That's right. That's right. Excuse me. The periodic table of elements lists atomic numbers for each element. For example, magnesium's atomic number is 12. Sorry about the focus going in and out. But down at the bottom, knock it off, would you? We see the atomic mass for magnesium at 24.305. Well, these atomic masses are going to take on a whole new meaning to you, and more about that will be explained later. For now, just trust me on this one. The best thing to do with this mass here is round it to 2 decimal places. So I'm going to say that the mass of magnesium atoms 24.31. And what I'm going to do here is I'm going to multiply that 24.31 by that 1 atom of magnesium. I'll do the same for chlorine. Let me go find chlorine on the periodic table, and there you are, chlorine. Rounded to 2. Let's see if I can move this in closer. Will it get focused? Oh, this is so annoying. I'm sorry about the focus issues. Maybe one day I'll get a better camera. 35.45. Whew, let's get that out of there. So we're going to do 2 times 35.45. And we're going to multiply these 2 little expressions out and see what they are. Okay, so 1 times 24.31, that's easy. That's 24.31. I'm not going to bother with the calculator. And then chlorine, let's see. Come on, chlorine. There we go. Let's clear that out. 2 times 35.45. That's going to give us 70.9. I'm going to make it 70.90. Keep in line with sig figs. That's kind of nice. 70.90. Great. Let's recap. I wrote down each element, magnesium and chlorine. Next to it, I wrote down how many each of those atoms appear in the element, or I'm sorry, in the compound. We got 1 and 2. Then I multiplied each of those numbers by the mass of that element from the periodic table, rounded to 2 decimal places. Now I've got these 2 results when I did that, and now all I'm going to do is add those results together. So 70.90 plus 24.31 gives us a whopping answer of 95.21. Okay, what are the units of measurement for formula mass? I'm going to tell you right now what they are. This chapter is about moles, so formula mass, the units are grams per mole, M-O-L. That's right, grams per mole. But wait, Mr. Moffat, we don't know what a mole is. I know, and that will be explained. For now, just trust me and go with it. Grams per mole are the units of measurement for formula mass. So there we go. We did one. We got a formula mass for magnesium chloride. Let's jump right into another example without any further ado. Let's draw a nice line here to separate that out. This is called sodium sulfate. Let's find the formula mass for sodium sulfate. Step 1, list the elements in sodium sulfate. Well, we've got Na, and then we have, all right, well, this is sulfate. When we balanced equations, we had a strategy where we kind of treated sulfate and other polyatomic ions as a single unit. Not for this. What you want to do is you literally want to list every individual element. Sulfate is made of sulfur, so I'm going to write down sulfur, and then oxygen. Oh, great. Now ask yourself how many of each of these elements or atoms of these elements appear in the formula. Well, immediately after sodium, we find a 2, so there are 2 sodium atoms. Immediately after the sulfur, there's an invisible 1. There, no, right, there it is, right there. Be careful, some of you will be tempted to say that there are 4 sulfurs. No. There's only 1 sulfur. Immediately after O is a 4 subscript, so there are 4 oxygens. Now let's find their masses on the periodic table and round them to 2 decimal places. Get back here. So for sodium, we got 22.99. So I'm going to multiply that by 22. Oh, that's terrible. Terrible handwriting. Sorry about that. 99. Sulfur's mass on the periodic table, rounded to 2 decimal places, 32.06. Some of them are already in 2 decimal places, so that's kind of nice. 32.06. And oxygen comes in at 15.999. We're going to make that the nice round 16.00. I'm now going to multiply each of these little expressions. I'm not going to put that on camera because it's weird. Times 22.99. It's going to give me 45.98. That's 8. 32.06 times 1, that's easy, 32.06. And then 16 times 4 gives me 64.00. Yes, I'm keeping 2 decimal places all around. And now we get to add them all up. And so we got 64 plus 32.06 plus 45.98. And if I did not make a typo, then the formula mass of sodium sulfate is 142.04 grams per mole. There, sorry that's squeezed into the corner. All right. Our formula masses should stay with the same 2 decimal places that we've been using all along. Last example, and this one is slightly more challenging because it has parentheses, so pay close attention to how we navigate around the parentheses. I don't want you to get lost. All right, this is called aluminum carbonate. Class, this is aluminum carbonate. Say hi. What is the formula mass of aluminum carbonate? First step, list the elements. All right, what do we got? We got aluminum, aka Al, carbon, oxygen, Again, the polyatomic ion, you want to regard each element separately. Let's find out how many of each of them there are. Immediately after aluminum is a 2, there are 2 atoms of aluminum. All right, now we got parentheses involved, and this is going to get a little crazy. So if you look at carbon, immediately after carbon, there's a 1, an invisible 1. So you might be tempted to put a 1 there. And immediately after the oxygen, there is a 3, so you might be tempted to put a 3 for oxygen. However, carbon and oxygen are trapped up in these nice parentheses, and immediately outside those parentheses is a number 3. That subscript of 3 means there's 3 of everything in this parentheses. So instead of 1 carbon, there's actually 3 of them. I multiplied this 3 by that invisible 1. And instead of 3 oxygens, there's actually 9 of them. That's right. I multiplied this 3 out here by that 3 inside there. If that confused you, let me know. You should at least watch this part one more time before we go on any further. All right, now we'll look up their masses on the periodic table, round them to 2 decimal places. Aluminum looks like 26.98. So I'm going to write 26.98. Carbon, 12.01. And then oxygen, 16.00. So 26.98 times 2 equals 53.96. 12.01 times 3, 36.03. 9 times 16, 0.00, 144.00. Add them up, and we're going to get a formula mass for this aluminum carbonate stuff. 36. All right, I'm going to start that fresh. Oh, made a typo. 144.00 plus 36.03 plus 53.96. Whoo! 233.99 grams per mole. And there you go. You might be tempted to just round that to 234. No, don't do that. Let's keep the decimals there. Other calculations down the road will become more accurate when we kind of leave decimal places alone. Don't be so quick to round and chop numbers off. We don't have to do that. Well, that's it. Okay? This is not that bad. And I'm going to give you plenty of practice to do. I'm going to provide you with plenty of practice in doing this. And make sure you take this one seriously because it is crucial to everything else we do for the rest of the year. For now, that's all. If you have questions, send me an email. This video went on a little longer than I wanted to, but that's all right. It was pretty good. I say to you all then, hand, which means have a nice day.